China builds roads faster than almost any other country on Earth, and the reasons behind that speed go well beyond cheap labor or government mandates. Here's how China's road construction process works, from the first planning stages to the final layer of asphalt, and why the scale of what's been built in the last 4 decades is genuinely difficult to comprehend. To understand the speed, you need to start with the numbers. China's expressway network reached approximately 191,000 kilometers by the end of 2024, making it the longest in the world, a title it took from the United States Interstate Highway System back in 2011. China's first true expressway opened in 1988, which means the country built that entire network in under 40 years. No other country has moved at that pace, and the infrastructure China built during that window reshaped the country's economy in ways that are still playing out today. Planning comes first, and it's more involved than most people realize. Engineers assess traffic needs and geographical features before a single machine touches the ground, using advanced software to model routes against environmental impact, cost projections, and long-term load demands. China's terrain makes this especially complicated. The country contains some of the most geographically hostile environments on the planet, including the karst limestone regions of Guizhou, the high-altitude plateaus of Qinghai, and the dense river networks of the Yangtze Basin. Routes that look straightforward on a map often require bridges and tunnels that would each be major engineering projects in their own right. Getting the planning stage right is what makes the speed possible later, because a well-designed route removes the delays that typically stall large infrastructure projects before they even begin. Material sourcing is where China's approach starts to look different from Western construction. Recycled asphalt and concrete have become standard inputs, which cuts costs while reducing the environmental footprint of each project. China also developed domestic production capacity for construction materials at a scale that means supply chain delays, a constant problem in countries that depend on imports, rarely slow a major road project. The materials still meet high durability standards, so the trade-off isn't quality for savings, it's efficiency on both ends. Roads built with these methods are expected to handle decades of heavy freight traffic, and in most cases, they do. The machinery China deploys is what most people notice first when they see footage of these projects. Massive automated machines lay asphalt continuously, completing road layers at speeds that would be unusual in most other countries. China also operates some of the world's largest fleets of specialized construction equipment, tunnel boring machines, multi-span bridge erection systems, and paving trains that can cover kilometers in a single shift. What makes this possible is that China treated construction equipment manufacturing as a strategic industry, building domestic companies capable of producing machines at volume rather than relying on expensive imports. Beidou, China's own satellite navigation system, now guides equipment with enough precision that each layer lands exactly where it needs to, which matters enormously for how long the road holds up under traffic loads. Drones have become a standard part of the surveying process, capturing high-resolution images and feeding data back to engineers who can track progress and spot problems in real time. That kind of monitoring used to require ground crews and significant delays. Now, it happens continuously overhead, and the data gets processed quickly enough to inform decisions the same day. And 3D printing technology has started appearing in component fabrication, producing parts on or near the site that get assembled quickly and generate less waste than traditional manufacturing methods. These aren't experimental pilot programs. They're being integrated into standard project workflows across the country. Labor is the other piece of the equation, and it's more nuanced than the usual narrative suggests. China can mobilize tens of thousands of workers on a single major project, and the coordination required to manage that workforce is itself a significant logistical achievement. Workers come from rural provinces, brought in through contractor networks that have been refined over decades of large-scale building. Safety runs alongside all of this. Workers wear protective gear and go through regular training, and China maintains strict enforcement of those standards on major projects. Fast construction doesn't mean cutting corners on the people doing the work, and the industry fatality rate has dropped substantially as training and equipment standards have improved. Financing these projects involves a system unlike anything in the Western construction world. Local governments in China have historically used land sales and bond issuance to fund infrastructure, with the expectation that new roads would increase land values and economic activity enough to service the debt over time. State-owned banks provide credit on terms that private lenders typically wouldn't offer, which makes long-horizon projects viable even when short-term returns are unclear. This system has drawn criticism. Some roads in less populated regions carry far less traffic than projected, and the debt burden on certain local governments has become a genuine concern. But as a mechanism for building infrastructure at speed, it worked. The G4 Beijing-Hong Kong-Macau Expressway is the example that comes up most often, and for good reason. Running just over 2,270 kilometers from the capital down through 5 provinces to the Shenzhen border with Hong Kong, it brought together advanced materials, GPS-guided machinery, coordinated labor deployment, and a planning framework built for speed. The road passes through dramatically different terrain along its route, requiring engineering solutions that varied significantly from one section to the next. What it demonstrated was that the system China built for road construction wasn't just capable of handling straightforward projects, it could adapt to complex conditions and still deliver on schedule. Other projects pushed the limits even further. Guizhou Province, which sits on some of the most extreme karst terrain in the world, has become the clearest example of what China's construction system can do when the geography offers almost no easy options. The province now holds nearly half of the world's 100 highest bridges, including the current world record holder, the Huajiang Grand Canyon Bridge, which opened in September 2025 and soars 625 meters above the Beipan River. Guizhou has built, or is in the process of building, more than 32,000 bridges in total, up from fewer than 3,000 in the 1980s. China didn't route around these canyons and gorges, it built through them. And the engineering capability that made that possible came directly from the construction ecosystem the country spent decades developing. What China has built isn't just a road network, it's a repeatable system where planning, materials, technology, financing, and labor all move in coordination. And that coordination is what turns ambitious timelines into finished roads. The network connected cities that used to take days to reach by rail or unpaved road, opened up agricultural regions to freight markets, and shifted the economic geography of an entire country. Whether that model transfers to other places with different political and financial systems is an open question, but the results in China are not. And the 191,000 kilometers of expressway that now cross the country are as clear an answer as any engineering project has ever produced.